Let us solve OpenStax University Physics, Volume 1, Chapter 3, Problem 80. A particle moves along the x-axis with velocity v of t equals 2.2 plus 0.2 divided by t, from 1 through 8 seconds. Its position at 1 second is 0. We will determine its acceleration and position at 2 seconds and 5 seconds. Because the velocity changes with time, the constant acceleration formulas are not the right starting point. We need the defining calculus relationships among position, velocity, and acceleration. The direction of the calculation matters. Moving from position to velocity, or from velocity to acceleration, requires differentiation. Moving backward from velocity to a change in position requires integration. These are definitions, so they remain valid even when acceleration is not constant. In this problem, differentiate the given velocity to get acceleration, then integrate the same velocity to get position. Differentiate the velocity. The derivative of the constant 2.2 is 0. Write 0.2 over t as 0.2 times t to the negative 1 power. Its derivative is negative 0.2 times t to the negative 2, or negative 0.2 over t squared. At 2 seconds, the acceleration is negative 0.050 meters per second squared. At 5 seconds, it is negative 0.0080 meters per second squared. The negative sign agrees with the slowly decreasing velocity graph. Position requires an initial condition. The problem gives x at 1 second, not at 0. Therefore, anchor the definite integral at t equals 1 second. X of t minus x of 1 equals the integral of velocity from 1 to t. Since x of 1 is 0, that definite integral directly gives x of t. Using the lower limit 1 also respects the velocity model, which contains 1 over t and is not defined at t equals 0. Integrate term by term. The constant velocity term gives 2.2 times elapsed time, t minus 1. The integral of 1 over time gives a natural logarithm. Written with units made explicit, the logarithm contains the dimensionless ratio t divided by 1 second. The position function is 2.2 times t minus 1 plus 0.2 times that logarithm. A computer algebra system can evaluate this integral, but it cannot decide where the lower limit belongs. Evaluate the acceleration and position functions at the requested times. At 2 seconds, the acceleration is negative 0.050 meters per second squared, and the position is 2.34 meters. At 5 seconds, the acceleration is negative 0.0080 meters per second squared, and the position is 9.12 meters. Positive velocity makes position increase, while the small negative acceleration makes that velocity decrease gradually. The reusable calculus kinematics strategy is to identify the function you know and the function you need. Differentiate when moving from velocity toward acceleration. Integrate when moving from velocity toward position. And let the stated initial condition determine the lower limit and integration constant. Finally, check units, signs, and trends. Those defining relationships work for constant and non-constant acceleration alike.